How's it going, everybody out there today? Do 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 do. Alright, so today's stream is in honor of Mikkel, or 4coder, from the Handmade Network community. If it were not for him, you would not be getting this engaging, extremely awesome content that is about to be delivered to you. So, if you're ready, here we go. The first thing I need to do is I need to update my 4coder version because I've released it to everyone else, but I have not yet given myself the updated copy. So let me go ahead and do that. Let's see. In the future, that does not belong there. Okay. Mhm. 'Now I need to build my customizations. Alright, now I am fully upgraded to the actual 409 release version. This is a pretty good version, people. I think that this one is pretty cool. Fucon, are you having Patreon issues? Is that what's going on? Alright. In the meantime, while you think about what to say there. Oh, we're on stream. Let me adjust my font size real quick. There we go. Oh no, Fucon, you can't see the 409 post because the Patreon didn't charge you properly. That's probably gonna last all month, isn't it? Since like somehow you got declined this time around randomly. I saw Casey Muratori posting that he was having weird things happen on Patreon too. After the stream, email me and we'll work something out so I can send you the new one. Ah, cool. Get in touch with support. Good plan. Alright. Anyway, today, what I'm going to do is I'm going to explain to the viewers the entire string library, the entire philosophy behind it, what everything in here does, why it's there. I'm going to fix all of the nonsense that makes it hard to understand when you read. And I'm going to write up into the documentation. Let me pull that up real quick. To this lovely documentation file you see here that was shipped today in 4coder 409. I'm going to add a section 4 for the string library. And it seems to me that before anything else, the first thing I want to do is add a table of contents into this introduction region, or even maybe above, like right here, table of contents, just to list out all the sections, because section 4 is going to go way below this, and section 3 is even going to get pushed down once I fill out section 2. So let's do that first. Table of contents on the HTML. Where does section 1 begin? Right there. Okay, so before section 1, let me just fprintf some stuff into that file. Yeah, so, let's see. doesn't need to be too fancy. I'll probably give it an H3 because it's not really a section level thing. It's one below that. Just say table of contents, and then I'll put a new line there, and then here we'll put a div, close div, or actually, well, let's just go with that. And each one of these is an anchor. They each have an href. Href goes to things like section 1, section 2, section 3, section 4. And what I could do is just say, like right here, section count equals 4. Break right there. Break that one off. And then take all that out. This can go at the very end here. And then in the middle, oh, I deleted it. Oh well, I'll just write it up again. Oh, I don't think I have I32 actually. Let me do ints. In the metagen system, I'm not using that for whatever reason. Go across all the sections, and with each section I'll do fprintf the file, an anchor that hrefs to. Those really need to have quote, or hrefs to something /a. Now I was thinking I would do section %d, but then the thought occurs to me that there's the same problem I had with the other thing, which is maybe I want sections by name actually, so it's more like section %s and then %s in here. And then what I'll have is just like section I dot ID string, section I dot display string, and then I'll just have a sort of section struct that's just ID string, display string. Then I will have we don't need section count there. What we need is section count to equal the array count of the sections array. And then each one of these is just a couple of strings, like so. So here I have introduction, 4coder systems. Oh, what else did I have? Where does section 3 begin? Types and functions. String library. And then what I'll do is sec intro. Oh, it already has the word section written right there, huh? Alright, so just introduction, 4coder systems. Whoops, come on. Doop, types and functions. And string library. Right, so that will list out all of those things, and Now what I need to do is make sure that they format in a way that I like. Furprint. I don't want furprint. I want fprintf. There we go. And while I'm here, let me update my build script temporarily to not build anything except for the docs, because I don't need to spend all that build time on building C++ code that I'm not editing at all. There we go. Alright, so now we have a table of contents, and it totally sucks because there's no sort of numbers on it, so it needs numbers. It needs a little section symbol. So the section symbol is sect %d, and %d is just I plus 1. And then I need to put these all in a list. So I said div, but let's try unordered list. And then here, let's put each one of these inside of a list item. Oh, that's in the wrong order. Whoa! What's going on here? F2. Ah, okay, that's just the... I thought I had a 4coder bug, but I was just accidentally in the French keyboard layout. Whew, I was gonna say I shipped this and it's got some sort of hang bug. It's not acceptable, but it does not. Alright, so that sort of looks table of contents-y. I don't like anything about that though. What's going on here? So I'm guessing H3s just have a really big margin. Yeah, I don't want that one to have any margin. And then I want these H1s. Do they not have any margin? That's an H2. Okay, so where did H3 even get their margin from? I see. Well, let's go tell H2 to use a margin. And let's tell this particular H3 not to use a margin. And then there we go. And then, to make things doubly good, what I should do is these sections here should be generated from the section system as well, just to be sure that they match up. In other words, this should be %s. And really what I want is sections 0 dot ID string and then display string. And the ID string goes right here where I set the ID of this thing to be that with a section right in front of it. The ID of that is section ID string, and then that thing is the display string. Alright, cool. So now that is actually just the header on all of these H2s. That's just what I write for all of them. And then I give it the sections that it wants. ID string, sections 1, display string. Okay, there we go. On to the next h2. There it is. Two and two. Alright, so that turned out exactly to be the same exact thing, which is what I wanted. And then I can take this, all the way down to here, and boom, I can undef the major section, define the major section to be number 4, and then this down here needs to be 3 and 3, and we now successfully have a table of contents with links and a string library section. There it is, string library. Now all I gotta do is write that. So, I promised a description, an explanation, an introduction to the string library for all my viewers before I get to actually writing the tutorial. So that is what we're going to do next. And that is this thing over here. So basically the philosophy behind the string library here is there's a number of concerns. Let me open up my Scratch document in order to write some stuff down. And this will help me to sort of figure out how to describe this. So this is a trial run of how I should describe the string library. You're getting my first take at describing it. For one thing, let me change this into non-C mode, because I'm probably eventually going to put the string structs into the documented type section somehow. But anyway, the idea was, or the idea behind it when I first made it, and to this day is still basically one of the motivating factors, is that I need to pass null terminated strings to a lot of sort of system level functions. Right, so that's one concern. I can't just say that I'm going to use non-null terminated strings everywhere, because the system level functions take null terminated strings and there's just nothing you can do about that. You have to be able to terminate your strings with null and give them to the system in that format. Now, with that situation, what that means is if I'm not careful, I end up with like the sort of a battle between where I'm using strings that have a size versus where I'm using strings that are null terminated. There's a boundary, right? And everything on one side of the boundary is non-null terminated, is size based, and everything on the other side is null terminated. Once you switch to null terminated, you don't really want to switch to size again, because then you might end up switching to null terminated again. You don't want to have a thing where you're copying the string over and over again, because some parts are using null terminated and some parts are using sizes. So there's this boundary that says, look, once you pass over this part here, you have a null terminated string. You should not convert it back to a size-based string. And the reason the conversion happens in this direction and not this way, the reason I don't say I normally assume have a null terminated string and sometimes I give it a size, is because the one that's more temporary is the null terminated one. I want to use strings that have built-in sizes, and I'll explain why I want that in a minute. But once in a while I have to, because of this constraint here, I have to convert to null terminated. So there's a rule, there's one boundary, and on the right hand side of that boundary you always pass things as null terminated strings. If a string if you believe a string to be null terminated, and you modify it, you leave the null termination in there, because you might pass that to somebody else who also needs it to be null terminated. And you never pass to someone who needs a size based thing again. Is sort of the hope, right? And so that boundary wants to move around, and I've been trying to move that boundary as close as possible to the system calls that actually need the null termination, so as to prevent too many conversions. But the second consequence of this is it makes me want to have systems in place that allow me to skip the copy altogether. In other words, if I set myself up correctly where I have this boundary and I never convert the wrong way, I never go from null terminated back to size, I can use that assumption to build something where I don't even need to copy the strings anymore. And that's the first trick that I came up with, which is this string struct here has 3 members. It's not just a string and a size, it also has a memory size. Now this isn't, the memory size, not every string struct gets used the same way. Some of them have a 0 in their memory size field. I know this is the case, even though they don't actually have a 0 memory size. And the reason they have that is because they're never going to use any of the functions that rely on memory size. The idea of memory size is that your string might actually have more memory available to it that's sort of allocated for it to use than what it's actually using currently, such as a null terminated character, or you know, if you've allocated 256 bytes and you've only used 32 of them, you have more space to use, and so on. So that's the second thing. Was I decided I want to support string operations such as concat. I'm not sure how to spell that the long way. Such as concating strings with as little overhead caused by copying as possible. Right, so the plan is we're going to have some clever way of allowing us to put null terminations on strings that we were passing around with sizes, and in addition to wanting to be able to for free null terminate any string, I also want the ability to do sort of string mutation without having to make copies of existing things. A lot of times what a string library might do if you want to concat 2 strings is allocate more memory and then concat the new thing in the new memory that's big enough for both of them. And what I want to do is say, let's avoid that. Let's assume that we always started with enough memory, and if we do run out of memory, we'll just report, hey, I ran out of memory. We won't try to fix that for the user. So we're trying to support this with very little overhead. We're not doing like memory allocations ever in the string code. And we're never doing copies in the string code unless the actual operation is a string copy, right? Okay. So that's the first 2 things that I wanted it to work off of. The next thing I decided to do, and this was maybe not as good of an idea. Those first 2 things are important points to base this thing on that have made it. It's my favorite way to deal with strings now. Anytime I have to do strings, I always import this because I've just gotten used to it partially, but also because it's the best thing I've ever used for strings in at least C or C++. So one other thing I decided to do was that in the entire library, there are still spots that show up that don't use the string struct. For example, and you can see right here, hold on, I gotta reopen it first. For some reason it was not treating it as code, which happens on occasion, and I gotta fix that 4coder bug that I haven't found yet. Excuse me. Okay, so right here we've got like a match, and what match does, and we'll get into those details of describing what each thing does in more completely later, but match is basically, are these 2 strings exactly equal to one another? And you can see I provided a version that just takes 2 char pointers, and so what's going on there? Well, the convention I decided to go with was, if you see a string parameter, you see a string struct, that means that it's a string that may or may not be null terminated, but it's a size and capacity the string is marked up with size and capacity, whereas here the string is null terminated. If it's not a string struct, this guarantees that the string is null terminated. And that's the sort of convention I went with throughout all of the code written here. The problem with that turned out to be that I also want that convention to be true at the 4coder API boundary, but I also don't want to force anyone to use the string struct. And we'll talk about a small problem I run into with this system, and ways that I may fix it in the future, or maybe it won't get fixed and it'll just be a spot where I take a small performance hit. But I'll talk about that once we have enough information to make sense. The point is, I decided to go with the convention Um, char star means null terminated. String means not necessarily null terminated. Right. So now here you can see if you have two null terminated strings, you can match them together. If you have two string structs, you can match them together, and if you have one of each, you can match them together too. And in general, I thought this might be useful just because, like I said, we have APIs that are using null terminated strings, but we also have APIs that are returning null terminated strings to us that are outside of our control. So sometimes you need an operation that works on a null terminated string, even though you don't want it to, even though you don't want to do it that way. Now, one thing you could do is just say that you always convert char stars to strings directly, and that's what this make string slowly does, but that requires an iteration across the string to find the zero. It basically requires a strlen call, and that's an O of n operation. It's kind of something I wanted to avoid. So this was one of my goals: is avoid unnecessary strlen type calls. Right now, if I get an ill-terminated string back and I really want to know its length, strlen isn't going to be avoidable there. But if I at one point knew the length of a string and then I lost that information, I don't want to have to re-get that information in order to do a match, right? So, for instance, in that case, what I did is I provide a null terminated version, and the null terminated version doesn't need to know the length of the string. That way, if I end up with a null terminated version of a string, I can operate at speed still, because it's still doing the same amount of character comparisons. It's just checking for a null terminator now. But it doesn't have to know the length to do that, so I don't have to strlen first and then check all the characters. Let's see, what are some other things that have happened in the system? Find. You can just see everywhere I've got versions of everything basically working with both char star and a string struct. Once in a while, like reverse find, I'll skip the char star version because I realize that the only way, so this is important, the only way to do this rfind substr was to string length first. You have to go to the end and then go back. So I just didn't provide the null terminated version. And in general, whenever a null terminated version isn't given, what that means is you can still convert that to the string, right? And then you can do the rfind on that. But what I want, basically what that means is don't hide too much performance, too much about the performance of an operation. So in other words, if I were to give the char star version of this, what that would basically boil down to is doing a strlen to find the end, and then going from the end backwards to do the find, which means that if I force the user to do a make string slowly and then call this, that it will be basically equivalent in terms of the operational cost, right? And so instead of providing the char star version here, I chose not to and force the user to convert to string first. That way they aren't misled about how fast that operation is actually going to be. Of course, the other thing I could do is provide an rfind char string one, which seeks forward and keeps track of the most recently found match, which would be arguably, potentially, maybe a little faster, but I felt like that was more complexity than what I wanted to try to support. So that's, something to think about. And of course, the other nice thing about this system is nothing's locked up from you. If you want to make a faster version for reverse seeking through a null terminated string, you can always just write your own to supplement this library. There's literally nothing fancy about this that really locks you in, except for the string struct. Let's see, what else? Okay, so far we've been looking at just the sort of the things which, if you look carefully, none of these edit the string at all. We do have substr, which I'll go into a little bit later, but none of these things here, it doesn't actually edit the string, is the point. This does a sort of this is for a sort of different use of the string system I'll discuss later. But in general, um, all these match functions here, all these find functions here, skipping white space, finding substrings, none of those modify strings at all. And so they all, you could think of them as sort of being functional versions. They all take non-pointers to strings, right? So another convention I came up with was that you can tell that something's going to modify a string because it takes a string pointer. If a function takes a string pointer, that string is being modified. Now what's interesting about that is the string pointer doesn't actually, the string struct here, sout, doesn't necessarily need to be edited at all. It's possible that an edit happens where I give you a string pointer and you don't actually change the string struct. Because remember, the string struct is actually just a char star pointer, a size, and a memory size. You might do an operation that doesn't change the pointer, the stir here, doesn't change the size at all, and doesn't change the memory size, but it's still going to be and never would, right? But the point is, it's still modifying the string, it's still modifying the thing that this points to. So anything that, even if it's just going to modify this char star string here, I still pass that as a pointer here just to signify that it's going to make an edit. And I think that does come into play at some point. If there's like a two upper might not actually be in the library. It might be something I added as a one-off thing somewhere else. But in general, that's always the convention, is that a string pointer means that string gets edited. And for the most part, I try to only do edits in string pointers, although you'll see it's not 100% only string pointers. For instance, this here is a char star getting edited. These down here are char stars getting edited. This is a char star getting edited. And that's it, right? So I have a few exceptions to that rule. Char stars can be edited. Let's see, what else goes on in here? Okay, so we're starting to get into this thing up here about supporting string mutation operations. And so one of the decisions I ended up making is string mutation operations can fail. And when they do, they return not 0 or something like that, right? I'll just leave it. String mutation operations can fail. Or here's how I'll complete it. And when they do, they may have partially modified the string's memory, but they never modify the valid part of the string when they fail. Alright, so that, for instance, is these bools here. Now, there's a little issue, which is I did provide stringed int as a char star value here. Oh wait, no, these don't even modify the strings, right? These are just reading a string and turning it into a int, which is why this is not a pointer and why that is a string. The only exception to the rule is just these three char dests here. Those do work as copies because I wanted my own string copy to a null terminated string. And I'll explain that decision as well. But anyway, string mutation operations can fail, and when they do, they leave them unmodified. The modified or the valid part of the string remains the same. In other words, this right here is sout here. So the modified string usually is the first parameter of the operation of the function, I should say. And so like this one is trying to append. This one here is trying to append the int as a string onto this string here. So what that means it's trying to do is it's looking at that string and it's trying to fill out all the characters, and if it turns out that there aren't enough characters, right? If the capacity, because remember, the nice thing about this library is the strings come with a memory size. So you can say, look, I'm only using a portion of my memory. So it's using the unused portion, it's expanding this size here and using the unused portion to contain the appended string. So what can happen is it goes, you know what, there wasn't enough memory to finish the append. In that case, the library guarantees that here it returns a false instead of a true, so you can detect that the string ran out of memory. And it guarantees that the string size did not change and any character in the valid part of the string did not change. Right, so it won't ruin existing strings, basically. Existing strings will continue to be correct. The only thing that can happen on a failed append is that you didn't manage to append something you wanted to. That's the only thing that can go wrong. So that is something important about the library. Let's see. Append float to string. Right, so copy. So all the copy operations, basically append and copy are similar, except that copy is just clears to 0 first and then appends. In other words, when you say copy source to dest here, you're taking this string and you're saying whatever this was, ignore it, drop its size down to 0, and then copy that into there. All of the appends are for building strings out, right? And you can usually just use append only unless you like want to 0 and append at the same time. And because a copy is really just a set size equals 0 and then append, you could literally write that code. You could write the code that does string size equals 0, append onto the string some source string, right? That would always be a available option too. The only reason I've actually provided the non-append versions is because, or I should say the copy versions, is so that you can copy to null terminated strings. And these are called copy fast unsafe, and the reason they're called copy fast unsafe is because they copy to the destination without checking the size and without checking the capacity. Like, they don't check that the copy is going to work. They have no way to check the copy is going to work, so they just hope that they can actually do it. So it's unsafe because there's no guarantee from inside this function that the memory doesn't overrun. And it's fast because it doesn't perform any checks. But I also aliased all those functions with just copy so that there's a way to copy in every direction except for some reason I don't have a copy aliased for string struct to this type, but I don't really care because I never use that. Yeah, copy checked. Oh, and the reason there's also a breakdown here of copy checked and copy partial. I never use those. I always just do copy, which looks like it does copy checked in this case and copy partial in this case. The difference is copy partial will, and the same thing is true for the naming scheme down here, a partial copy or a partial append means if the append or copy fails, if we run out of memory, do as much as you can instead. But like I said, I never use those. I always just rely on the copy version or the append version without the specific naming. Okay, so here's a pretty important function. It's not a very complicated function, but it actually ties into what I was talking about at the very beginning with all this original goal. Which is terminate with null. What terminate with null does is it modifies a string, but it doesn't modify the valid portion of the string. All it does is say, do I have any leftover memory in this string? Right? Is there at least one byte in the provided for this string that is not actually part of the valid string? If so, null terminate it and return success. Right? I'm gonna leave that the way it was. Otherwise, what it does here is it says null termination must be important, so it null terminates the previous thing. I think that's a mistake, and I'll probably get rid of that soon, because it never... Yeah, I think I'll get rid of it right now. But okay, so let me restate my point. It takes in a string pointer. The string pointer is not like a char star, it's a string pointer, so it's going to modify the string. But this is an example of something that's modifying the string, but it's not changing the string in any, like the string struct is not changing at all. It's actually just the char star that the string struct points to. But anyway, um, this this right here is checking that there's at least one byte that it can use, and null terminates, and then says success. We were able to null terminate this string. And the point of this is now, if you imagine that everywhere in my system I'm using these strings, and I'm trying to always have strings that have a little bit of spare memory, now whenever I need to pass a null terminated string to another API, I can just call this, and if it succeeds, I don't need to do any copying. Right now, I don't need to copy to a side buffer with an extra character, because this here just says, oh, there was a little bit of spare memory left over for this string. I'll just null terminate it in place and use that as the null terminated string. So now there's this cstring function up here, make cstring, which basically I don't ever use, but you could imagine using something that basically, yeah, I don't ever use this, which is why it doesn't really match the conventions. What it should say is something more like terminate with null the string and then that, and then make cstring, right? And I imagine I've just broken something in 4coder where like the one place where I used that. There we go. But anyway, the point is, make cstring, what it basically does is takes in the string struct and does the null terminate and then returns to you the char pointer from that string so that you can use it in the other APIs that use null terminated strings. So if that succeeds, it gives you the char pointer. What I should make it do, if I'm going to leave it in there, is say char star result equals 0, and then if this succeeds, then we'll do this. That way this function indicates failures by returning a null pointer. Okay, so anyway, that's the basic concept of how this system is going to handle conversion to null terminated. Let's see, after that, here's some stuff that belongs up here with match. Compare is sort of the basic string compare. It does a compare between two strings, doesn't modify them at all, and then it returns -1, 0, or 1 to indicate which one is greater than or if they're equal. All the append stuff we already looked at. Append padding. That's just a special purpose function I'll skip for now. Here's some more seek stuff. So right here at the end, what I have is a bunch of, what I should do is comment this. Whoops. Directory string management. So, now, there's a number of things that strings get used for, and I'll list them out here. One of them we just looked at. Things strings tend to be used for, right? One of them is managing file names, right? And so I have a bunch of helpers for that. Reverse seek slash starts from the end of the string and finds the first slash in the string, which is very useful when you're trying to do things like get the front of a directory, which is what I call the file at the end. Like whenever you've got a full path and you want just the name of the file, that's front of directory. Path of directory does the opposite. Whenever you have a full directory, it gives you everything except for the last thing in there. And there's various versions of this. So this one here does front of directory as right, so this is where I should probably describe something else before I describe that. So I'll skip that detail for now. Let's see. Some other things, if you want to set the last name, so you can say, like, basically this appends to the string the name of some file or whatever. Get a file extension out. This right here is a 1 for null terminated strings, because I guess I needed that at some point. This right here gives you the file extension as a C string, because I probably also needed that just randomly at some point. Remove last folder is basically a way of modifying this string. Very similar to get path of directory, I'm guessing. Some of these are a little redundant because I just add them as I need them. Let's see. And replace char isn't really in the right spot, but I added it here because this is where I actually first needed it. And it actually does modify the string, so it doesn't follow the convention correctly. Let's see if I can get rid of this one entirely. Well, there's not really a point in doing that, but replace char should take a string pointer, because even though it doesn't modify the string struct at all, it does modify the string. Like null, just like null terminated, like terminate with null doesn't actually need the string pointer, because it doesn't edit the string struct, but it edits the string that the string struct points to. Okay, so there we go. Yeah, so that's basically a quick rundown of all the functions. There's also this one, but that's like an experimental thing I'm not done with from recent stuff. So, let me describe substrings now, because this is actually part of what makes this interesting. And this feeds into a second use, which is I use strings for parsing text files and storing results, right? And what I mean by that is, for example, when I was making the doc generator, I used the string library there. And the reason I used it is because you can also use this whole system without the memory size anytime you want, as long as you don't use anything that takes a string pointer. In other words, if I look through here, like I said, there's the convention that if it takes a string pointer, it's going to modify that string in some way, right? So if you never pass a string pointer into any of the library functions, then your string shouldn't ever get modified, right? So that makes it very easy to tell whether you're doing anything that will modify the string or not. And what's useful about that is that means if you don't ever need to modify your string, you don't need copies of your string outside of the file. In other words, say I'm parsing up, let me pull up something with some docs in it. Right, say I'm parsing up this, right, and I've already loaded this file into memory so that I can read the file's characters. And I go to read this comment here, and I want to save the name of this parameter and then the whole string here that documents that parameter. Well, what this lets me do is say, look, I've already got a copy of this string in the file, right? The file data has a copy of that string. As long as I don't ever need to null terminate it or, you know, edit it in any way, why don't I just store a string that starts at C here and has a length to go over to here? And then as long as I never modify it, I can still do all sorts of other things, right? So there's this whole other way of thinking about strings, which is that you want to support mutationless operations where possible. And mutationless operations are nice for strings sometimes for things like parsing, because you can do like, oh, I've got this string here and this string here, and I want to concat them. Well, you do make the new string and store it in the new string rather than having to you know, sort of have memory set aside for that. But the problem is I did want to avoid having allocations happen, so not all of my operations are mutationless, just where possible. And the most useful place, it turned out, for me to do it where possible was substrings, right? Substrings don't really require copying at all. As long as the substring I make understands that that is a substring of a mutationless source, like the string that string is based on, the underlying character buffer is supposed to be mutationless, then I can just go ahead and substring all I want. So what I can do, and you probably saw this, is also in like the skip white space. If you saw me working on the documentation generator, I use things like skip whitespace, which also just operates on substrings. It even calls substring. Um, all it's doing is a mutationless creation of a new string, and so the new string is a different string struct that points at the same character buffer that underlies the string, right? So if you understand that, look, all of my strings need to be mutationless, or if I'm going to mutate them, I have to allocate a new string and copy into that space first. So, in other words, I can do something like pull this over here, take this entire string from there to there, and store that in one string, and call that the doc string. Right? I didn't mutate anything. I just said store a pointer to this D here, and store the length that gets me all the way to the end of that parenthesis. And that is my doc string. And then later I said, hey, start reading some stuff until you find an open parenthesis, and then treat that as a doc node. It then takes a substring of that, and all the substring is it starts at some other location within that original string. So in this case, it actually starts at the D still, and has a different length. They're two different string structs pointing to the same underlying system, and so there's never a copy. All it is marking a different substring of the original string. So it doesn't let you mutate the substring afterwards, so you have to manually keep track of which strings you're allowed to mutate and which ones you aren't. But I find that I never have trouble with that because I never have a pointer. The only time that I think you would get into trouble is if you started trying to store a list of strings and some of them could be mutated and some of them couldn't, then you've made a mistake. But as long as you always remember when you're creating a string type where that string type is assigned, then you can just say, look, this one I can reliably always mutate, and this one I can't, so I don't, right? If you have to mark it up in some way, you can even do that. If you absolutely had to, you could even store it as a const string, right? You could store a const string like this, but you'd have to do const cast then, or you could type def it, right? You could write something like type def string const string, right? And this just reminds you when you see it that that's supposed to be a mutationless string. Whatever you got to do. I can remember it on my own because, like I said, very rarely do I even have crossovers where I'm in one domain doing parsing and suddenly I need mutation. Or vice versa, where I'm, going to mutate this a lot, and suddenly I need a substring, and I really wish I could get the substring in a mutationless way. I never find myself in that situation. So, let me give you a quick look at how substring actually works. So substring just says, alright, we're going to take in this string struct, and you can see it's not a pointer because we're not modifying this, we're creating a new string struct. And then we're saying, okay, here's the start value where I would like the substring to start. Then the new string has, and you can see I never even set the memory size, and this is where strings come from that don't have a memory size, because once it's mutationless, the memory size is irrelevant. A mutationless string just needs its string pointer and its size, because the whole point of having the memory size is so that you can expand, append onto it and stuff. The other reason you can't have memory size is since it's doing something like parsing, in order to have memory size, you'd have to do an allocation, because you can't just write more characters past the end of this doc string because you're going to overwrite parts of the file that you're going to want to parse later. So the memory size becomes both conceptually irrelevant and also like practically something you wouldn't be allowed to use anyway once you're doing substrings. So that's the whole system. You've either got mutationless mode where you're doing substrings of things, or you've got mutation mode. But the really cool thing is all of the functions that take a non-pointer, right? If it doesn't take a pointer to a string, you can always pass a string to that. So I can compare two strings that are both substrings of a file, or I can compare two strings that both are based on their own like mutatable memory, or I can have one of either, right? These don't do mutations, so any of the functions that take a string struct that's not a pointer are safe for any type of string, right? That's the whole concept. So yeah, that's what all of the functions are built out of. And The last thing I'd like to discuss is the idea that this doesn't manage memory at all. So let me go back to Scratch. And yeah, Fucon says that I should be docking all of the functions, and I'm assuming he means all these string functions, right? They should all just get their own docs. The only reason they don't already have their own docs is because everything in API implementation has special behavior, right? Like this isn't, I don't just have a doc string here and then that's all there is to it. It also generates like this file called custom API, where every function that got exported ends up in here getting included in the abstract and getting various sort of versions of its own name, and so on and so on. So getting all of these linkages handled automatically, etc. So I don't want to use the exact same system. I can't just drop the string library into API implementation, but I do want to generate the string docs the same way I generate everything else, just with its own generator that's a little tweaked for it, for the string library. Okay, so the last thing I wanted to mention is the string library does zero memory management for you. What this means is it just never allocates anything. It never asks you to like give it an alloc callback. It doesn't do anything memory management. All that ever happens with memory is you pass memory into it, and it does stuff with that. If you don't give it enough memory, it just says, hey, I couldn't do anything with this. I'm done. Help me out here. Call me again. Call me later when you've got more memory, right? That's basically the plan for this entire library. So, what that leads to is that I've got a lot of different ways of initially making strings. Obviously, substringing is one way to do it, and the way substringing works is makes a new string where the memory is the memory of some other string, right? So it makes a new string, and the memory for this string is just the memory from some other string, right? I provided a string which already had its own memory, and the new string is just saying, hey, I'm gonna just use your memory because we're all mutationless anyway, so I can assume that you're not going to edit that that string there. The next way you can do it is there's just a straight up make string call where you give some memory. So make string just says the user has some memory they would like to assign to the string, right? So this is if you want to make a mutatable string, you can say something like, look, here's some memory, here's how big that memory is in mem size, and also you can provide a size which says here's how big the string that's currently stored there, because maybe this is a pointer to something that's already a string. This just lets you say here's how big the string is to begin with. This one here is similar, only it sets the memory size equal to size. So you basically say, here's the size of my string. It will set the memory size, so it's potentially mutatable, but you didn't tell it about any memory other than the memory of the original string in this case. A few other options. Make lit string. Use a string literal. How do you spell literal? Literal. Cool. Use a string literal as the memory, and use its as the memory, right? So in other words, here what you do is you put a string literal into this macro, and it does a make string on that and figures out the correct size based on that. Now this, since it's a string literal, usually you want to treat that as non-mutatable at that point, but it doesn't like enforce that in any way. It's just like nothing else enforces it. But usually, again, I don't find that I'm creating something from a string literal and then forgetting that I can't modify that thing. I don't mutate these things once I make them. And the last one is make fixed with string, which basically says use a um, uh, piece of memory from the stack for the right. And what that means is you can write code like this. And this is one of my favorite things: is anytime I need need a string, I can just allocate memory on the stack by going here's some like I've got my void foo, right? And then I can go here's some string space. And I say, you know what, if I had 256 bytes, that won't hurt anybody, and that'll definitely be enough space. And then I can go string str equals make fixed width string, and then I just pass in my local, my sort of string space there, right? And you can also store that string space, you can store it on the stack like I'm doing here. You can store it in a struct, wherever. You can store it globally, right? You just got to put a modifiable, and not a literal, because then you don't necessarily want to modify it, but a modifiable sort of fixed width array, and then you can provide that here, and it will use it as the space for the string. And then you've got a string that's completely empty, right? It's an empty string. Its size is 0, but it's got up to 256 bytes of memory at its disposal. And so then you can do things like, oh, you know, I need to null terminate an incoming string in some cases. So maybe what you do is say, like, look, I've got this do bar to me, or I'll just call this x, right? So I've got some string x, and what I want to do is I want to operate on x by calling bar on x, but the problem is bar doesn't take a string struct, it takes a null terminated string. So I really want to operate on x.str, the string portion of my string. But I need to make sure it's null terminated first, which means I need to do terminate with null on the x, right? Now what if that fails? Well, what'll I do then? So if I can't terminate this with null, what I should really do is say stir. Right, if I can't terminate that with null, then what I'll do instead is say, look, in that case, make a fixed width string out of my string space here, right, and then copy into the string from x, and then null terminate stir. And then finally we'll say, like, if that fails too, then we'll return early because we just haven't managed to get enough space for it, or like assert something like that, right? And so the idea here is this incoming string maybe is meant to be very small, and so maybe it doesn't have enough memory to do the null termination. So when we do this here, all we're doing is renaming x, right? This doesn't cause a copy. There's no copy constructors or anything like that. X and str are both pointers now to the same underlying string buffer, right? And so you have to be comfortable with sort of a C-style pointer, because really all the string struct is a modified pointer, right? So when I do str equals x, now str points to the same thing x points to. If I want to change what str points to, I have to do a make string call with some memory other than the memory from x, okay? So what I can do though is I can say, look, given the memory that I've already got from x, can I terminate with null? And the nice thing about a call to terminate with null is it doesn't modify the valid part of the string, right? So that's not a problem. And what I could maybe even do is say that that means that this doesn't need a pointer there. It's hard to say. But yeah, maybe if it doesn't modify the valid part of a string, it shouldn't have a pointer parameter. I'll have to think about that detail, because as I've described it, some of that has crystallized in my head more clearly, and I think this needs to be a non-pointer, since it'll fail anyway on strings it can't terminate, and any string it can terminate, it doesn't affect its size, it doesn't affect its memory size, it just affects the string, which means in theory, you could do it to a substring and it would just fail, and that would be fine, and then that would trigger the copy anyway. Okay, so anyway, the point is, you can try to terminate with null, and if that fails because there's not any memory left over in string, then you go ahead and make a fixed width string here, and that just means you're using some stack space to make a string, and then you're doing the copy into that string right here. And you see now I'm giving it a pointer to the str, copying x, and then I have to terminate with null again because just doing this copy doesn't guarantee there's any null termination. So then I terminate with null here, and finally I can call x.stir. Or if I want to, I can say, look, str is actually the one that contains the proper name because x did not get a new memory here, it was str that did. So that'll be more correct. Right? So that's the basic idea of what I wanted to demonstrate there, was using stack space to sort of just make one-off solutions to problems without thinking about memory management really at all for your strings. And that's one of my favorite features of this as well, is that it's just so easy to throw in something else that keeps, you know, switches over to a mutatable string if you need to or anything like that. Okay. So that's a full description of this thing. Now what I want to do is I want to figure out how the docs for this thing should look, how they should be set up, and how I should generate them. So thank you for bearing with me while I describe that library for the first time ever. Now how am I going to just do all of that in the docs? Well, I want to generate them to look just like the functions. That was odd. Okay, I want them to look just like these functions here. Like, I want it to have the section number, the name, the signature, and then this breakdown of parameters, return, description, and all, and so on. I also want to be able to use it as, you can see right now, this is one of the few places in my code base where I have like declarations and then definitions and different, like, not all in together, and I don't know that I want to keep doing that. So the first thing I'm going to do is I'm going to make some changes to this to basically eliminate. I want it to eventually be a sort of STB style single header include, but I think I'm not really into the idea of maintaining a file of this type. So I'm going to make a generator for the header file from a sort of source file. And the source file will contain all of the doc strings that it needs as well. Yeah, so let's start thinking about what I would need to do. Build all. Let me start building everything again because I've made some modifications and I want to make sure as I modify it that things are working. Alright, so here's where I call make cstring. So let's see me using this for a moment. Terminate with null the source path, and then take the source path and return the string. There we go. Okay. Now, I see. I see what those are for. Okay, I see. Boom. Yes. So I don't really want the separation between the declarations and the definitions anymore. There's a bunch of inlines. So first thing I'm doing is I'm undoing the sort of STB-ification of this because it's just more than I'm willing to maintain. Why, by the way, is my build process so slow right now? Is that because I'm streaming, or what's the deal? I guess I don't need to have you building right now, so let's cut you out. Okay. Okay, so that gets rid of the requirement that I do the defines beforehand. Now I want to get rid of the declaration, so I'm going to come over here and basically go through literally everything and just reformat this into my style. And along the way I'll include doc strings right there. This could be a lengthy and less exciting process than previous aspects of this stream. So this first portion here is just a bunch of character information, which I sort of skipped over because it's all very much not complicated. Ah, shoot, I just remembered I forgot to do anything with the fixing of the search function. I'll have to do that in the next update of 4coder. This is going to devastate my line count, by the way. Although I'll probably get rid of any of these that I can get away with getting rid of. So let me see. We're still building just fine. So let me see which ones I can get rid of. So you need 2 upper. I know you'll need 2 lower. Is white space. Whoops, could you... There we go. Char not slash. Oops. Char is alphanumeric. Char is hex. Char is numeric. Char is... I did it again. Char is alpha, and char is alphanumeric true. Char is slash. Char is alpha true. Alright, so none of these I will keep because they're not being used by anything. Okay, so there's all my character information functions. Now, string 0, why is that? Where is that defined? String 0. Alright. Let me add some commenting here. This right here is the that right there is the character helpers. String making functions. Hold on, so those macros there, define, I'll have to parse those. How do I want to do that? Doc export, define doc export, doc export, doc export. Alright, so now I've got a way of exporting defines. Expand string, I can doc export that as well. Alright, now what? Make string slowly. String size. Fucon, you're asking for seek line instead of only seek line char. What would be the difference? What would seek line do that you can't do with seek line char? How is that? How is seek line char not feature complete? Alright, if you don't care, well, here's my point. There's no point in having me write seek line. All you need to do is write a function that says buffer seek line seek equals seek line char line 1 return seek. Right, just include that in your own code if you want something, if you're not willing to type the 1. Oh, if you want to move up a line, then you want something different. If you want to move up a line and you don't want to always go all the way to the left, it depends. If you are okay with going up one line but ending on the left, like on the first character of that line, then this is what you would want right here. But, it sounds like what you're talking about is actually would require seek line char, because what you want to do is actually not actually seek line char, it's actually seek x, y, and then you want to give it the preferred x, and then the y position, and then you would say round down as false, and then say whether or not your view has unwrapped lines. And the way you get preferred x is you come in here and you go, look, I want my views preferred x. And the way you get your y is you go, look, I want my views cursor, I think there's actually a get cursor y or something like that. And then you'd have to double check that. But the point is you either get the unwrapped y or the wrapped y, depending on what mode it's in, and this does that for you. And then finally you need to do y minus equals view line height. And the reason that it's got to be done in XY is so that you can keep the preferred X correctly. Now, if you're only ever using monospace fonts, and you promise that you don't care if this thing breaks when you switch to the far superior proportional width fonts. Then what you want is, what you can do is simply, actually I don't know what you can do, because preferred x is measured in xy. So I don't know how you would, the only thing you could do is use the cursor's x and hope that that's correct behavior for yourself. But yeah, you actually do want the x position, you do want to set the character, because you're trying to seek to a position on the previous line that matches up with a particular x value. Unless you're just trying to go, like I said, to the beginning of the previous line, in which case, just put a 1 there. But there's no such thing as not caring about the character. It's a coordinate system. You're specifying where to go to. So it's not just like magically you say seek line and you seek to the previous line without changing the character at all. It's a absolute positioning system. It doesn't actually care at all where your current cursor is. It doesn't even have access to that stuff. But yeah, there's plenty of different ways you can, if you want to, look at how I do move up in the code and do something like that. But yeah, I can't do a seek that isn't in absolute and isn't specified in absolute positions. That's got all kinds of. Let me explain real quick, just for your benefit, why I don't want to do that. So, the way it's set up now, you say seek line char. You give some line -1 to go up 1, and you say like 1, and that puts you in the wrong spot. Or you say like cursor dot character, and that gives you the current position of the cursor, and you're saying I just want this to happen automatically. Well, there's the small problem with that, which is that what you're saying is you would still either have to pass the cursor and have it deduce the character for you, or you would have to do something like this and say there's a new seek type, which what it does is it reads some of its information from here and reads some of its information and then over here there's like a view which is not like a part of the seek data. You didn't actually specify this in the seek, but you're saying you want to implicitly get the position from the view. I'm not really comfortable with that implicit arrow. With that implicit arrow, the code becomes less purely functional. Over here, it's closer to a purely functional thing because it doesn't rely on the state of the view at all where it ends up, which means it's giving you 100% control. Anything where I take away some control and have an implicit arrow is kind of gross to me. It'll lead to bugs, in my experience. Okay, so anyway, I can export those, blah blah blah, make C string. So I've just decided that I've eliminated make C string from the code, right? I'm going to say there's no make C string. Substring. Now, before we do this, I want to quickly add I don't love the substring rule. I chose substring string start and substring string start size, but I wish I had substring string end and substring string start end. So maybe someday I will go through all of my calls to substring in 4coder and upgrade to this, or change to this, which I think I would be better used. But anyway, for now I'll just stick with the problem at hand, which is converting everything over to sort of my new style for documentation. substring slowly. Do I actually use that at all? No, I didn't think so. That's out. This is out. Tail string I do use. Tail string is just a trick for getting the leftover portion of a mutable string. Any string that has some memory left that could still be used, this just returns an empty string that uses all of that leftover memory. See, the size is 0, the memory size is whatever's left, and the string starts at the end of the S string, which needs to be named stir. I see. Doop. Let's see. Alright, so now the match function. So let me finish putting in the doc string. There we go. Alright. Alright, so whoops. Alright, looks good. Let's see, compare stuff. That's way down here because these were out of order. So, hold on, I'm done with string making. Those are all the substring things. So these are string comparison functions. Do, do, do. Cool. I want all of that to be up here. Alright, so let's see. Let me get these first. Oh. Let's see. So that gets all the match stuff. Finding characters and substrings. Alright. 1, 2, 3. Hold on, did I go back through and... Okay. So 1, 2, 3, 4. Okay. Let me put in the doc strings. Do 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 do. Alright, so now we have 3 find substring functions, one of them being our find substring. That can all just get moved up without any inline issues. Substring insensitive. Let's see. Substring. Alright, all this white space skipping stuff is basically a part of the substring system, so I'm going to put that there. Alright, has substring. Oh, those are inlines, I see. Alright. String integer conversions. Into string size. Into string. Appendant to string. append. That function doesn't need to get exported. And not sure what that was about. I didn't like that. Float to string size, float to string. Now we've got the string to int stuff. Color to hex string to color. Alright, so there we have, that's all of the string number conversion stuff. String, copy, and append. Copy. How do you spell copies? Okay. Append checked, partial, partial. Append. terminate with null. Need not be inline. Append padding. Now, some of these, first of all, let me get the inline ones done. Let's see, okay, the first two are not inline, so let me get those in there. Whoops. Doop-a-doo. Then here are all of the inline ones, which I basically just want to do that, followed by that. Okay, so that lays out all of the inlines there. And then the rest of these, set last folder, file extension slowly, file extension C, remove last folder, replace char. Now, I don't think all of these are in the right place or that all of them need to exist. So let's do some testing. Replace char, do you need to exist? Uh-oh. Okay, you're telling me append hasn't been given yet. Okay, so string copies and appends need to happen before the numerical things. Alright, so replace char. We have a length. I don't see why I shouldn't just do string fname equals make string. Okay. String. Let's go back to the directory thing. Alright, let's see if there's any other of these things. We do need remove last folder. File extension C. Do I use that anywhere? No, I do not. File extension slowly. Do I use that anywhere? No, I do not. File extension I use set last folder. I suspect I use that a lot. Yeah, but I don't seem to use this version, which is odd. I'm actually using the nil terminated version, is that what you're saying? Or am I not using either? Confused. Send me info. Oh, info file name, yeah, that's an old terminated string. Interesting. So all that's doing is appending. I don't know why that exists. I'm just going to do that manually. Copy into the full path the result of path of directory. FuCon, yeah. HandmadeCon 16. It's gonna be cool. I have yet to make any travel plans though. I should definitely look at what I've got to do around that time to get there soon. Alright, string set match. Is the last one, and it's just like right there and ready to go. And there we go. So the whole file now is converted to non STB style. So what I want to do is I want to close this file. I want to rename 4coder string.h to 4coder string.cpp. And now things should be broken. But that's fine. So what I want to do, we can go over to MetaGen, and let me pull up build all. Not build all. What I want to do is I want to only build the meta stuff again. There we go. And now I want to read 4coder string.cpp, which actually I want to call this like alright, so there's a couple options. Option number one is that I make this totally internal by doing something like this, which means it won't get included in the 4coder super distributions. And then I generate a 4coder string.h from that lays all the code out. What that would mean I would have to do is copy all the existing code over and then insert the declaration code and possibly drop the doc comments if I want to, or whatever I want to do there. That wouldn't be too crazy hard. The only thing that would be kind of odd is you'd got to do the work to generate the declarations, and you also want to wrap anything that is inline in a sort of defined system to make sure it doesn't get defined twice in the same. Well, basically, you want all of your inline things to get rearranged in their order, so you'd have to change the order in which things come out. I think I could do that. It wouldn't be crazy. The next option is that I generate a header that includes the CPP. It would have less flexibility, but then I don't have to generate the code. I don't have to. Then I can keep the property that the code that I'm writing and parsing is actual C++ code that goes through the compiler, and not just the spec code that generates other stuff. That sometimes has seemed like a slightly better option sometimes, but in this case I'm having trouble seeing the benefit because I'm going to lose a lot of flexibility if I do that, and I won't really gain anything except the fact that I now have two files floating around. The third option is that I just don't have a header file, and I don't make this a single file include style library. I think I want to go with the internal option and try to see if I can generate. I've never tried something like this yet, so it's something I want to try. The internal 4coder string.cpp will be the main source that I use to generate the 4coder string.h. Okay, so that means that what I want is basically to come all the way down here, generate custom headers. It's going to be a part of this because the docs also are getting parsed at this time. But let's see. String code equals file dump internal 4coder string.cpp. Parse equals the string parse. And then what I'll do is, first of all, do I actually need the parse? I always forget what the parse does. That's just the token stack. String tokens equals make token make there it is. Alright, so now let's do this. CPP file. Let's see, code equals the string code. The parse, no. token stack. The tokens equals the string tokens. Alright, Fucon, see you later. And then I'm going to take the CPP file and there we go. I can finally parse the tokens with this. Wait, no, with this. Although what I should do is rearrange this to say tokens equals that. And then I parse that, and now I've got the tokens. Next, oh shit, that was scary. Next, I've got the tokens. I want to do a loop across the tokens, so that looks like this. Alright, so I'm looping across all the tokens, and now what I want to do is during my first loop I'm just trying to extract data. I will have a second loop later in the future that I go across all the tokens and I drop them all out. So let's see. API implementation. Internal 4coder string. FCPP string. Character helpers. String making functions. Yeah, so the first thing I'm looking for is I'm looking for either f-string inline or f-string link. And now one thing for me to think about is how I make inline work across C and C++. In C there is no inline, so you define f-string inline to be static, and it basically just works exactly the same after that. And then for the other ones, yeah, okay, I see. That's not a big deal. What I am going to need is declarations. Define f-string decal, f-string decal. So what'll happen is it'll read until it finds that token when it's doing the output stage, and then it will it'll know what's going on and drop all the declaration work right there. Yes. Okay. So feel like I can just do... Yeah, I'll leave with that. Alright, and then I'm doing my loop across. I'm looking for f-string inline and f-string internal to let me know where it sees... Oh, and doc export. Right. So I'm looking for an identifier that is not in a preprocessor body, like so. And I want to get the lexeme from that token. Just like I do down there. And then I want to say, look, if that lexeme equals blah, where blah is f-string inline, then do this. Then do that. Then do this. Right. Whoops. Alright, so far so good. So now it's looping across all of those tokens from the string internal file over there, and it's finding these points that declare, hey, here is a thing that's important, here's a thing that's important, and so on. So now what I want is, in these first two cases, I want to do something similar to the logic that happens with parsing the doc strings in the API implementation file. So I'm just going to have parse function equals false. That can be an int is inline equals false, and then if we're in this case set that to true, parse function true, parse function true, and then I'll have parse doc false, and right there it'll do parse doc true. Alright, so now it's figured out whether or not it should do some work, and then I'll do, if I'm parsing a function, else if I'm parsing the docs. Alright. Now if I'm parsing a function, the things I need are the return name, the function name, and then the breakdown of the parameters, all of which I've already got code written to do. But let's see. Here's the thing. This stream is now 2 hours and 18 minutes long. It's verging on 19 minutes, which, you know, is a pretty long stream. I'm feeling like I want to cut it off right here, and maybe later today or some other time in a future stream. Maybe tomorrow I'll continue streaming this endeavor. And until then, I think I'd like to take a break, because I'm feeling like it's a good time for that. So thank you for watching, if you've been watching. And commenting and whatever. I'll be streaming again tomorrow, and until then, see you guys around. Bye.